Well, hello, friends. Welcome back to school. I hope you had a great Easter vacation. It was restful. We miss you, and we hope to see you soon, but we're jumping right back into our Geometry Chapter 8. We finished all our lessons, and it's time to review. So we have this ready-to-go-on assignment that I'm going to go over each problem with you, actually. It's 1 through 13 odd, page 569. I'm going to go ahead and work through each problem with you to prepare because we have a quiz this week on Wednesday and then a chapter test on Friday. So we'll be doing the practice test and the chapter review. But first, here's our ready to go on. And I'm happy to walk you through each problem of this assignment to help you however I can. So the first problem is an angle of depression problem where you have this blimp seeing a stadium at an angle of depression of 34 degrees. It gives you the height or the altitude of the blimp at 1,600 feet. And then it very clearly asks for the horizontal distance between the blimp and the stadium. So that helps you be clear that this is your x versus the hypotenuse here, because they say the horizontal distance. Okay, so then the real trick here is we've got to get the degrees that they give us somehow within the actual triangle that they've drawn in the textbook here. And the simplest way, there's two ways to do that, but the simplest way is to say, well, we have the alternate interior angles. So whenever they give you this angle of depression here, you know it's congruent to this angle here. And so this is 34 degrees. And then once we have that, we can see that we have the opposite dimension here, and we have the adjacent that we're looking for. Opposite, adjacent. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. That is TOA, opposite, adjacent. Tangent to opposite over adjacent. So we're going to go tangent of 34 equals 1,600 over x. And then as we've been reviewing, or as you've been practicing this, we can see that to solve for x, in this case, when x is on the bottom, we simply need to switch the x and the tangent of 34. We'll find this by that x will be equal to 1,600 divided by tangent of 34. And so once we get to that point, that's calculator time. So we'll go ahead and pull this out. And we'll say 1,600 divided by tangent of 34. I can do this all in one step. Equals, and it says we're going to round to the nearest foot. And I can see that's feet, so our units are all clear. So our answer is 2,372, right, 0 keeps it rounded to 72 feet. And that is our solution. So pretty straightforward and easy once we've got to know our SOHCAHTOA, so I can set up the correct trig ratio. I also have to know where the 34 goes. You don't want to put the 34 here because that angle is not the angle of depression. That's not 34. The other way you could solve this problem is if you hadn't placed the 34 here like I did, you could have used the complementary nature of these two angles to solve it this way. And so the alternative way of solving this would be we do 90 minus 34, that's 56. So this angle here is 56 degrees. So you could have solved this problem looking at it from this angle, 56, opposite over adjacent. And so alternatively, I'm not going to do it again, but tangent of 56 is equal to x over 1,600. And if you calculate that, tangent of 56 times 1,600, you're going to get the exact same answer, 2,372 feet. Okay, so that's using tangent on an angle of depression problem. Next, we have a couple problems using law of sines and the law of cosines. If we remember, the law of sines is sine of A over its corresponding side length is equal to the sine of angle B over its corresponding side length. So the key to use the law of sines is you have to have a pair of opposite angles and sides that you know both of. So the first thing I'd look at determining which, if I'm going to use this or later the law of cosines, I see do I have a side and an angle across from each other. Doesn't matter whether it's A, B, or C. Don't let that throw you off. But as long as I have a pair, and in this case I do, I have a pair right here, and nicely enough, they're asking in this problem for angle A, and that lines up perfectly with this pair here. So the law of sines is going to be our approach to number 3. So we take the sine of the angle that we know, 118, over its corresponding side, 20, And then that is equal to sine of the angle I'm looking for, which in this case is angle A, over its corresponding side, 14. And so there now we have our proportion. And so you solve your proportions, you're going to cross multiply. Okay, so we get sine 118 times 14 equals sine A times 20. Okay, and we'll calculate this in a second, but to get sine of A by itself, I'm going to switch colors to show this. We're going to divide by 20. Divide both sides by 20. And so sine of A is equal to sine of 118 times 14 over 20 equals sine A. Okay, so let's go ahead and calculate this and see what it looks like. So sine of 118, I'll do it real slow, times 14 divided by 20. And I get this nice ugly decimally answer, which is what we'd expect when we're doing sine of an angle. So we have now point, and whenever you do these, if you can't store it in your calculator, I would write it out to 4 decimal places. 0.6180 equals sine of A. Okay, so how do we get A once we have this? Well, we just need to do the opposite of sine, which is the inverse sine, sine of -1, or sine -1, not sine of -1, but inverse sine of that number, and we will get what our angle A is equal to. So that's where we have to shift here. We use sine to the -1, 0.6180 equals, and we're going to round this to the nearest tenth, and so we get the answer 38. I'm sorry, the nearest angle measures to the nearest degree. So that's 38 degrees. 38 degrees. Okay, so again, we used the law of sines because we had corresponding sides and angles that matched up. We set up our proportion, we cross multiplied, and that gave us this. Then we solved that, and we slowly just solved for A. We removed the multiplying 20 by doing the opposite operation, dividing. And then we remove the sine of A by doing the opposite operation, inverse sine. And that gives us 38 degrees for angle A. Okay, and that takes us then to number 5. Same situation, but a different problem. And we look at it and we say, can I use the law of sines? Well, we're supposed to find side XZ. XZ, which I'm going to call side Y, because it's across from angle Y. So we need this side. So immediately I see, look, I have a situation where I need that, but the other angle, I don't, but I know this side, and I don't have this angle here, and I have this angle, but I don't know this side. So potentially, you might think I can't use the law of sines. However, whenever you see that you have 2 angles within a triangle, you can easily calculate the third angle, because we know that they add up to 180. So if I do 180 minus 92, and I also subtract the 62, I can see that the remaining angle, angle Z, must be 26 degrees. So 26 degrees. Now all of a sudden, there it is. That's what I need for the law of sines. I have the side length and the angle measurement that are needed in order to use the law of sines. So we're going to do this just now from here on out, just like number 3. Though you'll see it's slightly different because we're finding a side versus an angle. So I always start with the 2 I know. Sine of 26 over 8 is equal to, this time I know the degree, sine of 92 over side Y. But the way we solve it is exactly the same. I'm going to cross multiply. So I get 8 times sine of 92 equals sine of 26 times Y. And so how do I get Y by itself? Well, the opposite of multiplying by sine of 26 would be to divide by sine 26. So I'm going to divide both sides by sine 26. And so I can see there now I have what y equals. Y is equal to 8 times sine of 92 divided by sine of 26. This is the correct answer. We just need to formalize it or actually calculate on a calculator if we want the specific numerical answer. So let's walk our way through that. I can do some of it quickly. Sine, I will just start from the beginning. 8 times sine of 92 equals that number. And then we need to divided by, I'm going to put this in parentheses so that the sign gets calculated right, sine of 26. And hit equal, and we get 18.2, which is correct. 18.2. And again, that makes sense. A side length of 8, it makes sense. This is around 18. That seems reasonable. We didn't get some weird, funky answer. So y is equal to 18.2. 18.2. So notice we had to find the third angle, which is very easy to do, so that we could have this crucial pair of corresponding angle and side so that we could set up our proportion, cross multiply, and then solve our proportion or continue solving for the missing variable. Okay, which finally then brings us to number 7, the third problem of this set using the law of sines or law of cosines. And in this case, you can see we have all three sides. Now, if you remember from previous videos, SSS is one of the two situations where you have to use the law of cosines. The other one is side, angle, side. In both of those situations, you do not have this crucial pairing of angle and opposite side that you need in order to solve. So here we will be using our law of cosines, which is just a wonderful thing to memorize. C squared equals a squared plus b squared minus 2 times ab cosine c. Oh my goodness. And if you remember how that works, is that the c is the angle or the side you're looking for. So depending on what you're looking for in this particular problem, it's either going to be here or here. A and B are always the sides that you know. So if we look at the problem, we are looking for angle F. Angle F. So that means 4 and F are the C's. And in this case, I know the side, but I'm going to have to find the angle. So knowing that, I can begin to plug it in. So 4 is my C. So we start with 4 squared equals the other two sides, doesn't matter the order, I don't care which one's A or B, equals 5 squared plus 6 squared minus 2 times 5 times 6 cosine, and in this case I cosine, I'm going to put F because I'm looking for F, cosine F. And now it's just a matter of not messing up the arithmetic as we solve this. 16 equals 25 plus 36 minus 2 times 5 times 6. 5 times 6 is 30. 30 times 2 is 60, so that's minus 60 cosine F. Okay, crucial moment. We're going to add 25 and 36, but don't subtract 60, because 60 is not alone. It's multiplied by cosine F. So that's the number one mistake people make in solving law of cosines is in a problem like this, they would subtract. They'd go 25 plus 36 minus 60. Don't do that. We can only add these two. So we get 16 equals 25 plus 36 is 61 minus 60 cosine F. All right, so now we're going to we need to get F by itself. First thing we want to do is subtract 61 from both sides. All right, so let's just check that. 16 minus 61 is going to give us negative 45. Oops, so this cancels out. So we get, moving over to here, we get negative 45 equals negative 60, running out of room, cosine F. So now we have, because this negative 60 was always being multiplied, negative 60 times cosine F, so the opposite of that is going to be dividing by negative 60. Really just, if you're struggling with law of cosines, you just need to practice several problems and the repetition will get more familiar. All right, so we have negative 45 over negative 60. That's actually going to be 0.75. It's positive because you have these two negatives. So we have 0.75 equals cosine f. All right, and just like number 3, when you don't know the angle, but you have your ratio. And by the way, you could enter 45 over 60 in your calculator too. It's all up to you how you want to calculate it. But the opposite of this is going to be opposite cosine. Opposite cosine of 0.75. And that will tell us what angle F is. And what I meant was, so I can sit here and go inverse cosine now, because I'm trying to find the angle of 0.75 is 41.4 degrees, or rounding to the whole degree, like it says, 41 degrees. I could have, just so you know, if you didn't want to do the 0.75, I could go ahead and just do inverse cosine of 45 divided by 60. Same thing. That's 0.75, so we still get the 41 degrees. That is our answer. 41 degrees. Again, if that's tricky, just watch this segment over a couple more times and work your way through it. You could also be practicing some of the problems from 8.5. But work through a couple law of cosine problems and you'll get more comfortable. Again, mostly remembering the C, where you plug in your C, that it's either the angle or the side that you're looking for in a law of cosines problem, and then being just kind of careful and methodical. This is why I emphasize being neat in showing your work so that you don't make an arithmetic error as you solve for your missing variable. And again, if you want help with this or any other problem, please just Zoom chat me and I'll help you live on anything in any way that I can. Okay, the last 3 problems are actually, I think, a little easier. I think the toughest one on this is probably the law of cosines, but we're all different. But looking at the last 3 problems, getting into 8.6 in vectors, which again might have been the most strange thing, but hopefully you're seeing it's not terribly difficult once you understand what it's talking about, is we have the vector here of 3, 1, and it's asking to find its, we have to graph it, and then we have to find its magnitude. Okay, and if you remember, the way we graph these is just like an XY, oops, that's not good, let's actually use the lines, is treating them like X and Y coordinates. So this just means over 3, up 1. But a vector is an arrow showing the direction of something and its strength, its magnitude. So we've got 3, 1 here. And all the magnitude is the length of this line, which is just a hypotenuse, something we learned way back in chapter 1. It's the hypotenuse. We know the length, 3 and 1. I don't even have to draw this once you really understand what you're doing, but I'm using it to explain what we're doing. And so then we can just use the Pythagorean theorem. A squared plus B squared equals C squared. Okay, so 3 squared plus 1 squared equals C squared. That's 9 plus 1, and then 10 equals C squared. And the way that you undo squaring something is you square root it. That's your algebraic principles. So C is equal to the square root of 10. And they want you to actually calculate that. And once you put that in your calculator, take the square root of 10, you get that C equals, again, square root of 10 is correct, but if you need a decimal answer, is 3.2 approximately. Approximately 3.2. So that's the hypotenuse of this little triangle we've formed, or the magnitude of this vector. This thing, whatever it is, it's moving, usually at a velocity. It means it's moving in this direction. In this case, we'd be going kind of northeast if we think of cardinal directions, but with a magnitude of 3.2, whatever, meters per second, miles per hour, depends on what it is. But it's just the length of a hypotenuse. And number 11 is just like it. We have to graph it. You'll see, though, even 11 is even easier. But we'll go ahead and graph it at our x and y's. 0, 5. Over 0, up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we've got something going due north, straight up. 0, 5. So we can do this the slow way here, but also just remember, magnitude means the length of this line. Because this isn't a tricky diagonal line, I can actually just count its magnitude. 1, 2, 3, 4, 5. Oh, I'm done. The magnitude of this is 5. if we thought of the Pythagorean theorem, you see we get the same answer. We'd get 0 squared plus 5 squared equals c squared. That's 0 plus 25 equals c squared. Square root both sides. And we're back at where we started. C equals 5. So whether you kind of work your way all the way through it, or you just remember what magnitude means is just the length of that vector line. And if you can see that without having to use Pythagoras, well, then that's your answer, 5. So same exact process on two different problems, finding the magnitude of a vector. Now 13, we could go ahead and find the magnitude of this vector. If it said find the speed or the magnitude of it, we do the exact same thing we did in 9 and 11. But in this case, number 13 is asking for the direction. And when they ask for the direction, they want to know the degree, the angle in which something is moving. And so we could have done that with either of these. They're all set up the same, but they're asking for different things. These two are magnitude. This they want to know, and we'll draw it. Just why not? But it wants to know it's the direction that it's headed at, going over 5, 1, 2, 3, 4, 5, up 3, 1, 2, 3. So we have a vector doing this, and we're not finding the magnitude in this case, though we could. We want to know this, the angle, so that we can describe its direction. And so that is, we're still going to use these numbers, but that is a trig problem, where again, we know the height is 3, we know the base is 5, and so now we go through SOHCAHTOA. SOHCAHTOA. Opposite hypotenuse, adjacent hypotenuse, or opposite adjacent. Opposite and adjacent is what we need, so this is tangent. So tangent of our angle is opposite 3 over adjacent 5. And again, you don't have to draw this. Once you get good at this, you can do this very quickly even in your head. But nothing wrong with working slowly and carefully. Inverse tangent of both sides, just like we did on the law of sine problem. All right, so now we take our calculator. All right, here we are. So clear that, what we did last. Inverse tangent, because we're finding an angle of 3 divided by 5. We check it, round to the nearest degree, 31 degrees. So this is heading at an angle of our Pokeball here, our theta is 31 degrees. And depending on what they want, you can be even more accurate. If we do this with our cardinal direction, draw a little compass on here, north, south, west, and east, we can see that it is headed at 31 degrees, or sorry, east, 31 degrees from east, 31 degrees north. So that's a more specific answer. Again, depending on your choices on a multiple choice test, etc. Okay, so vectors. You can find the magnitude, which is just the length of the hypotenuse, or you can find the direction, which is usually, it's actually always going to be a tangent problem, unless for some reason they give you the magnitude, where you're just finding the angle formed by one of the horizontal or vertical lines of a vector, and then designating, okay, I'm headed 31 degrees north of east. And so now I know either how fast something's moving or what direction it's moving. And those are the two essential aspects of working with vectors. All right, again, please contact me if you need help. This is your, I'll set them all there in case you want to freeze this and look at it at the same time. That is your ready to go on review. Wednesday we have a quiz, and Friday we have the full test. Tomorrow I'll be assigning the practice test so that we can begin preparing even further. All right, take care.